Okay, here's a physics problem regarding work and friction. And here's what it says. After hitting a long fly ball that goes over the right fielder's head and lands in the outfield, the batter decides to keep going past second base and try for third base. The 62-kilogram player begins sliding 3.4 meters from the base with a speed of 4.35 meters per second. If the player comes to rest at third base, A, how much work was done on the player by friction, and B, what was the coefficient of kinetic friction between the player and the ground? Well, let's start with the first part here. Alright, so we're going to solve for work here. And we have a velocity, we have a weight, we have mass, and work equals force times distance, but we don't have a force here. So let's just do work equals the change in kinetic energy. Let's use that formula. So change in kinetic energy equals, you should know, 1/2 m and then delta v squared. So 1/2 mass times the final velocity squared minus the initial velocity squared. So work equals 1/2 mass, so there we go, and then v final squared minus v initial squared. So if we're solving for work here, we don't need to rearrange this formula at all. We know that the final velocity is going to be 0 because he stops, and the initial velocity is going to be 3.4, so we could just right away when we're plugging things in just make that be one number. So work equals 1/2 of mass. What's mass? 62 kilograms, and then multiplied by what would just basically be the negative initial velocity, so negative 4.35 meters per second. And don't forget that it's squared, so you square that part. And this is just going to turn out to be negative 587 joules. So it's actually really simple. We didn't even need to use the distance. Okay, so that's just the work done by friction. Now they're asking for us to find the coefficient of friction. So we know again that work equals force times distance. You might be asking what we would use for force here. Well, of course we're going to use the force of friction. Well, what is the force of friction? Do we have enough information for that? Well, sure. Force of friction is just mu times normal force, right? That's just a regular physics formula that you should know by heart. So we could just substitute mu times normal force into there, because we know what the normal force is, right? It's just a person sliding on flat ground, so obviously it's just going to be his mass times gravity. So let's rewrite that to work equals mu normal force times distance. And since we want to solve for mu, we're just going to take this part, divide on both sides. So it'd be mu equals normal force times distance. Oops, my bad. Bad algebra. Mu equals work divided by normal force times distance. So now that's just not that hard. All it is just plugging in numbers. So mu, the coefficient of friction, equals work, and well, we've got work. It's negative 587 joules, and then we're going to multiply it by the normal force, and the normal force is just mass times gravity. So let's do 62 kilograms times gravity, which is negative 9.8 meters per second squared, times distance, which is 3.4 meters. And so the coefficient of friction is always positive, so that's why we have this negative right here and this negative, so they're going to cancel out. So the coefficient of friction is just going to equal 0.28, and that seems reasonable. That seems like a good amount for sliding on dirt, and that's just work and friction.